Okay, and this is a nice sort of gentle end to the mock, all right, but still one where people have a bit of trouble, so let's have a look. We're looking at the particles found in an atom. Notice here, we're not looking at our radiation, our particles to do with radiation. We're not looking at alpha, beta, gamma. We're looking at electrons, protons, and neutrons. Okay, well, neutrons, protons. We're told the mass, the relative mass, okay, and then we're asked, and the relative charge, and we're asked to kind of fill in the missing bits. Now, be careful. Bits that trip people up. 1, the mass cannot be negative. Often students will put a -1 here on the neutron. Okay, mass cannot be negative. The mass of the neutron is actually the same, roughly, as the mass of the proton. So we're looking for the number 1 here. Sometimes we write the letter U. Okay, let's see if that comes out. It's interesting, U there. Okay, but it's because sometimes we say the mass is 1U, 1 unit, but you're expected just to write the number 1 here. Okay, no need for a plus or a minus, just a 1. Relative charge is the next one. Now, relative charge is something that can be negative or positive, and hopefully you remember that there must be one of each, because in a neutral atom, we've got to have a balanced electrons and protons, i.e. balanced negative and positive. The electron carries the negative charge, and the proton carries a positive charge, -1 and +1, and that's 1 mark for each of those. Okay, and I really would hope that most people will be able to get one of them, but as I said, often people do have trouble with this mass. They think that there should be a -1 there. It's not, it is a plus. Then we've got our atoms A, B, C, D, and E, and we're going to be thinking about looking at protons and proton numbers and mass numbers, or nucleon numbers. Now, we're asked to state which atom has a proton number of 3. To do that, we're going to count protons. 1 proton, 2 protons, 1, 2, 3 protons. So we're looking at the answer C for this question. We'll do a little confirmation, 1, 2, 3, 4, 5, 6. Well, that's 6 there and 6 again. Let's remember that, 6 and 6. And therefore, the one with the proton number is going to be atom C, because atom C has got 3 protons. Proton number of protons, C. Okay. Nucleon number 6. Nucleons are the total number of things in there. Total number of neutrons and protons. So again, we just do a bit of counting. 1, 2, 3. No. 1, 2, 3. Again, no. 1, 2, 3, 4, 5, 6. Aha. Looking like C again. The answer is C, but we'll just rule out the other ones. Well, we had 6 black dots here, and we've got 1, 2, 3, 4, 5, 6. That's 12. 1, 2, 3, 4, 5, 6, 7, 13. Okay. And so again, the answer here is CC. Now this, I reckon some students have trouble with this because they think, well, it couldn't possibly be C twice. Well, clever CIE, they've done this to us. A little trick question there. Both answers are C. The following one then says which ones are isotopes. We've got to remember what an isotope is. An isotope has the same Z, so the same number of protons, but a different A. In other words, different nucleon number. And the answers here is D and E. Why? Well, we said at the beginning, we have a proton number of 1, 2, 3, 4, 5, 6, and 6 here. So they've got each got 6 protons. However, they have different numbers of neutrons. Okay, in this case we had 6 neutrons. In this case would be 7 neutrons. All right, this is actually carbon 12 and carbon 13. They are the same element, but they are isotopes because they have different mass numbers or different nucleon numbers. Okay. As I said before, not the hardest question that we've got here. However, certainly one that that causes a few issues. So make sure you check your answers before you move on.